In this problem, you need to find out the number of 3-digit numbers that can be formed using the digits 1, 2, 3, 4 and 5, assuming that repetition of the digits is allowed and repetition of the digits is not allowed. Let's see the solution of this problem, how we shall proceed with this. Now we shall write down the given data. Given digits are 1, 2, 3, 4 and 5. We know that in a 3-digit number we have units place, tens place and hundreds place. In our first part of the problem, it is given that repetition of the digits is allowed. When the repetition of the digits is allowed, the hundreds place can be filled with 1 or 2 or 3 or 4 or 5. Therefore, hundreds place can be filled in 5 ways. As we are given that the repetitions are allowed, this tens place can also be filled in 5 ways. In a similar way, this units place can also be filled in 5 ways. Now let us recall the definition of the fundamental principle of counting. If an event can occur in m different ways, following which another event can occur in n different ways, then the total number of occurrence of the events in the given order is m into n. So this is known as fundamental principle of counting or multiplication principle. You have to remember this. Therefore, the number of 3-digit numbers formed is equal to 5 into 5 into 5. As you can see here, hundreds place can be filled in 5 ways, tens place can be filled in 5 ways and units place can be filled in 5 ways. Therefore, the number of 3-digit numbers formed is equal to 5 into 5 into 5, which gives us 125. Hence, when the repetition of the digits is allowed, the number of 3-digit numbers formed is 125. So this completes the first part. Now, let us move on to the next part of the problem. In the second part of the problem, it is given that repetition of the digits is not allowed. When the repetition of the digits is not allowed, hundreds place can be filled with 1 or 2 or 3 or 4 or 5. So this implies that the hundreds place can be filled with any of the given 5 digits in 5 ways. Since the repetition of digits is not allowed, and moreover, any one of the given digits has already occupied hundreds place, now the tens place can be filled in any one of the remaining 4 digits in 4 ways. In a similar way, this units place can be filled in any one of the remaining 3 digits in 3 ways. Therefore, by fundamental principle of counting or by multiplication principle, the number of 3-digit numbers formed is equal to 5 into 4 into 3. So this gives us 60. Hence, when the repetition of the digits is not allowed, the total number of 3-digit numbers formed is equal to 60. So this completes the second part. With this, we have come to the end of the solution of this problem. In this problem, you need to find out the number of 3-digit even numbers that can be formed using the digits 1, 2, 3, 4, 5 and 6, given that the digits can be repeated. Let's see the solution of this problem, how we shall proceed with this. Given digits are 1, 2, 3, 4, 5 and 6. In any 3-digit number, we have units place, tens place and hundreds place. As the number that is to be formed is an even number, this units place can be occupied by 2 or 4 or 6. As these are the 3 even numbers which are available in the given digits, as you can see here. So this implies that the units place can be filled in 3 ways. Since it is given that the repetition of the digits can be allowed, the tens place can be occupied by any of the given 6 digits in 6 ways. Since there is no restriction on hundreds place, this hundreds place can be filled in any of the given 6 digits in 6 ways. Therefore, by fundamental principle of counting or by multiplication principle, the total number of 3-digit even numbers that can be formed using the given digits is equal to 3 into 6 into 6. So on multiplication, this gives us 108. So with this, we conclude that when the repetition of the digits is allowed, the number of 3-digit even numbers that can be formed using the given digits is 108. So this completes the solution. In this problem, you need to find out the number of 4-letter code that can be formed using the first 10 letters of English alphabet, given that no letter can be repeated. Let's see the solution of this problem. First of all, we shall write down the given data. We are given the number of letters that can be used to form the 4-letter code is equal to 10, as it is given that the first 10 letters of English alphabet. As it is given that the repetition of the letter is not allowed, the first letter of 4-letter code can be filled with any one of the given 10 letters of English alphabet in 10 ways. Since the first place is occupied by any one of the 10 letters of English alphabet, the second place can be filled with any one of the remaining 9 letters of English alphabet in 9 ways. Since repetitions are not allowed, this third place can be filled in 8 ways. In a similar way, this fourth place can be filled in 7 ways. Therefore, by fundamental principle of counting or by multiplication principle, the total number of ways in which the 4-letter code can be formed using the first 10 letters of English alphabet is equal to 10 into 9 into 8 into 7. So on multiplication, this gives us 5040. Hence, the number of 4-letter code that can be formed using the first 10 letters of English alphabet when no letter can be repeated is 5040. So this completes the solution. In this problem, you need to find out the number of 5-digit telephone numbers that can be constructed using the digits 0 to 9, given that each number starts with 67 and no digit appears more than once. Let's see the solution of this problem, how we shall proceed with this. First of all, we shall write down the given data. Number of digits that are to be there in the telephone number is equal to 5. First 2 digits of the telephone number is equal to 67. We are also given that the number of digits that can be used to construct the telephone number is 0 to 9. That means the total number of digits that can be used is equal to 10. Now observe the problem once again. The telephone number should start with 67 and no digit appears more than once. That means repetition of the digits is not allowed. As repetition of the digits is not allowed, the number of digits that can be used to fill the next 3 places of the telephone number is equal to 10 minus 2, which is equal to 8. Now observe here once again, these 2 we have subtracted because the first 2 digits of the telephone number has already occupied by 6 and 7. That implies 6 and 7 cannot be used further. Therefore, we have to eliminate these 2 digits from the total number of digits that can be used. Therefore, the total number of digits that can be used to fill the next 3 places is equal to 8. As the repetition of the numbers is not allowed, and moreover, the number should start with 67, this third place can be filled in any of the remaining 8 digits in 8 ways. Since one digit of the remaining 8 digits must have occupied the third place, the fourth place can be filled with the remaining 7 digits in 7 ways. In a similar way, this fifth place can be filled with any of the remaining 6 digits in 6 ways. Therefore, by multiplication principle or fundamental principle of counting, the total number of 5-digit telephone numbers that can be formed as per the given condition is given by 8 into 7 into 6. So which gives us 336. Therefore, we conclude that the number of 5-digit telephone numbers that can be constructed using the digits 0 to 9 if each number starts with 67 and no digit repeats more than once is 336. So this completes the solution. In this problem, it is given that a coin is tossed 3 times and the outcomes are recorded. Now, you need to find out the number of possible outcomes in this experiment. Let's see the solution of this problem. Given that a coin is tossed 3 times. When a coin is tossed once, there will be 2 possible outcomes. They are head and tail. Now we shall represent head by capital H and tail by capital T. When a coin is tossed 3 times, there will be 2 possible outcomes each time. Therefore, by fundamental principle of counting or by multiplication principle, the total number of outcomes is equal to 2 into 2 into 2, which gives us 8. Therefore, the possible 8 outcomes are HHH, HHT, HTH, THH, HTT, THT, TTH and TTT. So with this, we conclude that when a coin is tossed 3 times, the number of possible outcomes is 8. So this completes the solution. In this problem, we are given 5 flags of different colors. Now, you need to find out how many different signals can be generated if each signal requires the use of 2 flags, one below the other. Let's see the solution of this problem. First of all, we shall write down the given data. We are given the number of flags of different colors is equal to 5. Number of flags required for each signal is equal to 2. Now to make a signal, the upper part of the flag can be filled with any one of the given 5 colors in 5 ways. Now, one of the 5 different colors has already occupied the upper part of the flag. The lower part of the flag can be filled with any one of the remaining 4 colors in 4 ways. Therefore, by fundamental principle of counting or by multiplication principle, the total number of different signals that can be generated is equal to 5 into 4, which gives us 20. Hence, the total number of different signals that can be generated if each signal requires the use of 2 flags, one below the other, is 20. So this completes the solution.